Okay, we want to prove that the difference in squares of consecutive even numbers is always a multiple of 4. Now I'm going to teach you some fundamentals of any proof question first. So we always start by saying that we're going to have an integer and we normally use it n or m. So then if we're looking at even numbers, which is what we're going to want in this one, the first even number is going to be represented by 2n. Then the next one would be 2 more than this, so it's 2n plus 2. And then an odd number can then be written as 2n plus 1, because it'd be 1 more than an even, and the next one would then be 2n plus 3. And that's what it means by consecutive, is the next one. So we want the squares of 2 consecutive even numbers. So the first two numbers would be 2n and 2n plus 2. And we want the squares of these, so we want to square them. We also want the difference of them, so actually it's going to make more sense if we put them this way around. Now it tells us that we want all of this to equal a multiple of 4, so we need to just keep in mind that at the end we're going to want 4 outside our brackets. Right, we now need to multiply out our brackets. I always find it helpful to write it out. And for the second term here, it's going to be 4n squared, so I can put that in, not forgetting I times everything. I could have put some square brackets around this to make sure I keep that minus. So multiplying everything out, then I've got 4n squared, then I'm going to have plus 4n plus another 4n, so that's plus 8n, plus 4, and then minus 4n squared. So this ends up giving me 8n plus 4. Going back to the fact that we want it to be 4 on the outside of our brackets, we can now put 4 brackets and then 2n plus 1 inside. To finish, just make sure you repeat what was in the question. What's it been asked for? We're proving it is a multiple of 4.